Okay, here we go. Example 69. Here we're asked to solve the inequality, and we're told to report the final answer in interval notation. All right, so that's how we'll report all our final answers in this video. All right, in interval notation. Okay, here we have 4x minus 7 is less than or equal to 9. We want to isolate x on the left-hand side of the inequality. So let's add 7 to both sides to get started with that. Okay, so once we do that, then we have 4x is less than or equal to 16. All right, and then we divide both sides by 4 to isolate x. All right, and the 4's cancel on the left-hand side, and that gives us x is less than or equal to 4. Okay, so let's visualize this on the number line. All right, we're going to shade everything to the left of 4, and we'll use a dot at 4 to indicate that it's included in the solution set. All right, so in interval notation, remember what we do is we read the number line from left to right like it's a sentence in English. Okay, we have everything from negative infinity all the way up to 4, and 4 is included, so we use a bracket. All right, this is our solution set. Okay, let's move on to the next example. All right, here we go. Example 70. Here we have negative 2x plus 3 is greater than x minus 5. Okay, so let's take everything involving x to the left-hand side and all the constants to the right-hand side. All right, so let's subtract x from both sides to get started with that. All right, and that gives us negative 3x plus 3 is greater than negative 5. Okay, so then let's subtract 3 from both sides. All right, and that gives us negative 3x is greater than negative 8. Okay, and then to isolate x fully, we need to divide both sides by negative 3. Okay, when we do that, the negative 3's cancel on the left-hand side, and we need to flip the inequality, right? Because we're dividing by a negative number, we're going to change this from greater than to less than. All right, we have x is less than 8/3. All right, let's visualize that on the number line. 8/3 is 2 2/3. Okay, so this is where the interval starts, and we shade everything to the left of it. All right, so in interval notation, our answer is negative infinity up to 8/3, and 8/3 is not included, so we use a parenthesis there. All right, this is our solution set. Okay, moving on to the next example. All right, example 71. Here we have a compound inequality. Remember, a compound inequality is two inequalities occurring at the same time. All right, so for this, we want to isolate x in the middle. All right, so to do that, let's subtract 2 throughout. All right, subtract 2 everywhere. And that gives us negative 6 is less than 3x, which is less than or equal to 16. Okay, so next we need to divide throughout by 3. Okay, and the 3's are going to cancel here in the middle. All right, and that leaves us with negative 2 is less than x is less than or equal to 16/3. All right, let's visualize this on the number line as well. Okay, we have everything from 2 up to 5 1/3, right? That's 16/3. Okay, so this interval in interval notation looks like this, right? It's negative 2 up to 16/3. Negative 2 not included, but 16/3 is included. All right, so that's our solution set. Okay, let's move on to the next example. All right, here we have an or compound inequality. All right, the previous problem was an and compound inequality, but here we have this. All right, so what we want to do is solve each of these inequalities separately. Okay, so let's divide our work like this. All right, and just isolate the x on the left-hand side for both of these inequalities. All right, let's start with this one on the left. Okay, here we're going to add 5 to both sides, and that leaves us with 2x is less than negative 6. Okay, and then we need to divide both sides by 2 to fully isolate the x. All right, and when we do that, the 2's cancel on the left-hand side. Okay, and that leaves us with x is less than negative 3. Okay, So this inequality on the right, sorry, on the left has been solved, right? We have x is less than negative 3. Okay? Over here on the right, to isolate the x, the first thing we need to do is subtract 1 from both sides. Okay? And that leaves us with 5x is greater than or equal to 5. All right? And then we need to divide both sides by 5. All right? And the 5's cancel on the left-hand side. And that leaves us with x is greater than or equal to 1, right? 5 over 5 is just 1, okay? So we have two intervals here, right? We have x is less than negative 3 and x is greater than or equal to 1, okay? So let's join those together with the word or, okay? And let's take this to the top of the screen, all right? On the number line, here's what it looks like, right? We have everything shaded to the left of negative 3. Negative 3 is not included. And then we have everything shaded to the right of 1, and 1 is included. Okay? So that's what that looks like in interval notation, right? This is everything from negative infinity to negative 3, or, remember this symbol means or, and we have everything from 1 to positive infinity. All right? That's our solution set. Okay? Let's move on to the next example. All right, here we have an absolute value inequality. All right, so we need to get rid of these absolute value bars somehow and get this blue stuff isolated. All right, so to do that, we need to recognize that whenever we have an absolute value less than something, that translates into an and compound inequality. All right, the blue stuff inside is greater than negative 7 and less than positive 7. Okay. So that's the meaning of absolute value is less than something, right? It translates into this, okay? So let's subtract 3 throughout, all right, to isolate this x in the middle, okay? And that's going to give us negative 10 is less than 2x is less than 4, okay? And then we divide throughout by 2, all right, and the 2's cancel in the middle here. And that leaves us with negative 5 is less than x is less than 2. All right? So let's visualize this on the number line, right? We have everything shaded in between negative 5 and 2. And negative 5 and 2 are not included, so we have circles there. All right? Which means in interval notation, we need to use parentheses, right? We have everything from negative 5 up to 2, and negative 5 and 2 are not included in the solution set. All right? So this is our final answer. Okay, here we go. Example 74. Here we have an absolute value that's greater than something. All right, so to get rid of the absolute value bars here, we need to remember that greater than corresponds to an or compound inequality. All right, we take the stuff inside, right? We take the blue stuff and set it less than the opposite of the right-hand side, and we also set it greater than the right-hand side itself. Okay. So we have an or compound inequality that we need to solve, which means we just need to divide up our work like this and solve each of them one at a time. Okay, so let's start here on the left. We're going to add 1 to both sides. All right, and that gives us 3x is less than negative 10. All right, and then we divide both sides by 3. All right, and the 3's are going to cancel on the left-hand side, and that leaves us with x is less than negative 10 thirds. Okay, let's solve this inequality on the right now. Okay, let's add 1 to both sides. Okay, and that leaves us with 3x is greater than 12. Okay, and then let's divide both sides by 3. All right, and the 3's cancel on the left-hand side, and that leaves us with x is greater than 4. Okay, so we have these two intervals here, and we're going to join them together with the word or. All right, that's the union of two intervals. Okay, so let's take this result to the top of the screen. Okay, and here is what the two intervals look like. All right, we have everything shaded to the left of negative 10 thirds. All right, that's negative 3 1/3. And then everything shaded from 4 up to positive infinity. Okay, so this is what the solution set looks like in interval notation. All right, so this is our final answer. Okay, great. Let's try another one. All right, here we have the absolute value of x minus 7 is less than negative 4. All right, this looks fishy, right? There's something weird about this, okay? The left-hand side is always positive, no matter what value we plug in for x, okay? The left-hand side is an absolute value. Remember, an absolute value always gives us a positive number, okay? So that means it's impossible to satisfy the inequality, all right? A positive number being less than a negative number is negative. It's never true, okay? It's never true. So it's impossible to satisfy the inequality, which means there's no solution, okay? And on the number line, this is what this looks like. No solution means we just leave everything unshaded, all right? Here's the symbol we use to indicate the empty set. All right, we have the empty set as our solution set, okay? There is no value of x we can plug in here to make this inequality true, all right? So let's look at another one. Here we have x minus 20, absolute value, is greater than negative 3, okay? And look at this. The left-hand side is always positive no matter what value we plug in for x, okay? The absolute value will always give us a positive number, all right? So a positive number being greater than a negative number is a given, all right? That's always true. So the inequality is always satisfied no matter what value we plug in for x, okay? So that means that the solution set is all real numbers, okay? So here's what that looks like on the number line, all right? We simply shade everything, all right? All real numbers, that's our solution set. So in interval notation, that looks like this, right? It's negative infinity up to positive infinity. Okay, so that's our final answer. All right, let's try one more problem. All right, this is a word problem, and it's an application in chemistry, actually. It's a pretty interesting problem. So let's dive into it. All right. The volume of a certain gas is given as V equals 20T, where V is the volume measured in cubic centimeters, and T is the temperature measured in degrees Celsius. All right? If the temperature varies between these two values, right, if it varies between 80 and 120, we're asked to find the set of possible values for the volume V. All right? So let's write down what we know. All right, the problem tells us that T varies between 80 and 120. All right, so we have a compound inequality here. This is an and compound inequality. All right, and we also know that V equals 20T. All right, so let's multiply throughout by 20, okay, to see what that gives us. All right, that looks like this, right? We have 1600 is less than or equal to 20T is less than or equal to 2400, okay? Let's take this result to the top of the screen. Okay, this is the compound inequality, all right? And we know that V equals 20T. So in the middle here, we can replace 20T with V, all right? So V, the volume, varies between 1600 cubic centimeters and 2400 cubic centimeters, all right? So if we wanted to report that answer in interval notation, here's what it would look like. All right, we have 1600 up to 2400. Okay, those are the possible values for the volume V. Okay, that does it for this video. Thank you for watching, and like and subscribe.